context, about 74% of all websites globally use HTTPS by default. So that means there's a whole quarter of unencrypted web traffic globally. And with Let's Encrypt, then we will look at how to make sure that we achieve 100% or close to 100% encryption for the traffic. So a little bit about our expert. Philip has a very long profile. I'll try and summarize it. So he's an independent consultant and also a FreeBSD committer, contributing mainly to kernel. He's also a member of the FreeBSD security team. He was one of the main organizers of FOSDEM, which is the largest annual open source software conference in Europe from the early 2000s until 2015. And once in a while, you can convince him to teach, and we are lucky to be among the few who have convinced him to be with us today. So if you have any questions, as I said, you feel free to post them, and then Philip will answer them, or will try to answer as the session progresses. So over to you, Philip.
Thanks, John. I have a very long-winded biography, but I'm not all that interesting. I am going to put up some slides, if I can find them. Here we go. I do many things in life. Most of the things I do are low-level development, grubby things with kernels and bootloaders and device drivers. But along the way, I've also stumbled into quite a bit of infrastructure. And one of the pieces of infrastructure I maintain is I help run the FreeBSD.org cluster, which distributes the FreeBSD operating system to users and is actually the source control system for the FreeBSD operating system. The FreeBSD cluster has about 150 physical machines, and I think last time I counted, we have about 400 jails or virtual machines, if you like. And unlike many systems on the internet, or many clusters on the internet rather, we believe that our cluster is a collection of independent machines that all just happen to work together. So we don't have something like a trusted network where we VPN in, and then once you're inside the box, you have access to everything. Instead, the FreeBSD cluster, every machine is mutually untrusting, so nothing trusts anything. The web server does not trust the backend. The Git repository does not trust the web server. Nothing trusts anything. Authentication doesn't trust where the user comes from. There's no trust anywhere. So we encrypt all the things. And the only way you can do this is by automating it. And this workshop, or this tutorial, actually, it's a 90-minute version of something I've taught in half a day and a day. It just goes through some of the automation mechanisms you can use for automating your Let's Encrypt process specifically. So onwards and upwards, the usual process for generating a certificate, if you have a website or something else that requires a certificate, is you generate your certificates, by which we mean you generate a key pair, usually RSA, and a little bit of metadata on that certificate to say, what does this certificate belong to? And you take these keys and the metadata and you build something called a certificate signing request. And the certificate signing request is a blob of ASN1 encoded data. It's terrible. It's encoded further in X509. It's not very exciting, but you built this using your piece of software. And then you take this certificate signing request and you convince a certification authority to sign this certificate for you. What the certification authority does is they look at the public key and they verify that it is indeed a public key, and then they look at the X509 metadata that goes with it, which is usually a common name, and maybe there's a country in there or an organization. Could be anything. There's the old joke that you can put anything in the DNS. There's an even older joke that you could put anything in X509. But ultimately, at the end of the day, the certification authority needs to sign that certificate, and then you get a certificate which you can put on your web server or your file server or your printer, if you like, and you repeat this annually. I was chatting earlier with the instigators of this workshop, and I was told that you can get from if you're working for the university, you can get free certificates from John. He will take your certificate signing request. He will be your certificate authority, and he will give you your certificate. But the important part of this slide is that you have to do this annually. The other problem of this slide is that you have to do this, you have to convince your certification authority to sign your certificate, which you're basically buying an integer from the certification authority. A signature on a certificate is nothing magic, it's just a number. And the certification authorities are primarily answerable to their shareholders. They're not answerable to you or to anyone else on the internet. So at the end of the day, what are you doing? You're giving them money, and they're giving you a number. But that, I can rant about this for several hours, but that doesn't get us anywhere. But more fundamentally is that anything that you have to do annually, you tend to do manually, and that's error prone. The generating a certificate signing request, you need to sacrifice a chicken and plead with OpenSSL to give you something that your certification authority will like, and unless you script it, you're going to make mistakes, and it's not going to be fun. But also, you're just going to forget. Anything that you have to do once a year, you are just going to forget unless something screams at you. Case in point. Earlier today, I tried to subscribe to the KeNOG mailing lists, and I discovered that the lists.nog.ke server had a certificate that expired on the 25th of June, which it was last month, I think. So for the last month, everyone who tried to connect to the mailing list for the KeNOG was given this nice little box that says, we don't love you, please don't scream at the systems administrator. I didn't scream at the systems administrator, I just said, I'm going to laugh at you this evening. And here I am laughing at you. This problem has been fixed meanwhile, so it's
Hi, Philip, can you hear me?
Hello, yes, I can.
I'm sorry
I can't
for interrupting.
see you.
Are you sharing your slides yet?
I am, I was.
Oh, I'm
Did
sorry.
you not see them?
I don't seem to see
Stop
them.
sharing them now. Let me, where's this window gone? The problem with having a big screen is that you get lost in it. There we go. Let me share again. Are they visible?
Yes, now it's visible.
Oh, right. I'm sorry. You didn't miss anything exciting. You missed a couple of bullet points, and you missed my rant. CAs being answerable to their shareholders. Good. Thank you. Please do interrupt me if I go off on tangents or if you don't see what I'm doing. I don't bite much. But earlier today, I saw this little window, which hopefully now you see, when I tried to subscribe to the KeNOG mailing list, and it said, that's great. We have an encrypted web server, but our certificate has expired. I was pleased to see that the list server was using Let'sEncrypt, but Let'sEncrypt works a lot better if you actually renew your certificates from time to time. And we will get into that a lot more as this talk progresses. I'm just going to keep this window up like this, because then I can see you and I can see my slides. And there's no secret in the future slides anyway. So let me talk about Let'sEncrypt a little bit first. So the model I just talked about earlier is you send your certificate signing request to someone and you give them some money and they give you a certificate, and you're basically buying some numbers, and once a year you give them some more money and they give you some new numbers, which nice work if you can get it. But Let'sEncrypt is a not-for-profit certification authority, and they do exactly the same thing as most of the for-profit certification authorities, except they do it for free. By which I mean you don't give them any money and they give you your numbers. And Let'sEncrypt certificates are trusted by pretty much every device you're likely to find on the internet. There have been a few attempts earlier in history to try to set up a free certification authority, but none of those actually took off. There was CA Cert, if anyone remembers that. But none of those actually took off because the web browsers and later on the mobile phones just wouldn't include them. Let'sEncrypt managed to get enough credibility, enough of a team with big enough sponsors to convince the likes of Mozilla, Apple, Microsoft. Hello.
Yes, I'm sorry, I keep coming back. I
You're not
think
seeing my slides?
if you have the slides on the slideshow format, then it would be more visible than what you have now.
All right, I can do that. How about that?
Yes, that's perfect. That's perfect.
All right. It's all about your comfort. So there have been a couple of attempts at doing free certification authorities, but they never really took off. The Let'sEncrypt organization they're a charity, they're a foundation, and they're sponsored by a couple of big names on the internet. And they managed to convince initially Mozilla, which was a big player in the web browser field, and then Apple and Microsoft and all the other big manufacturers of devices and software to include their root certificates. So if you have a Let'sEncrypt.org certificate, it will be trusted by everyone on the internet, which is great. Also setting them apart from most of the certification authorities, Let'sEncrypt.org is automatic, which means you don't interact with any humans. You deal with machines, and you send bits in standard formats. And I'll come to the standards in a bit. And it's all automatic and it works well. Secure, well, it's just as secure as every other certification authority. But in this context, Let'sEncrypt.org is auditable and audited. So you can go and verify that their processes, that they do what they say they do, which leads me to transparency as well. Let'sEncrypt.org, every time you issue a certificate, they will log that certificate being issued to certificate transparency public logs where you can check them, and you can also monitor these logs. So if someone goes and issues a certificate for one of your domains, which should not be possible, they can't do this surreptitiously. You will be able to find it if you monitor the certificate transparency logs, which is beyond the scope of this presentation, but you can go and do this. And finally, Let'sEncrypt.org, they're an open and cooperative group of people. So they have a lively discussion forum on the internet, and they also participate in the internet standardization process. The protocol they developed is an internet RFC now. I'll come to that in a moment. And it is documented and is developed in the same way as other internet standards are. So developed in the same way as DNS is, developed in the same way as TCP. So it's an open and cooperative sort of enterprise. Now, earlier today, I was told that some people are uncomfortable with things that are free. So if you are married to the idea of paying people for your numbers, you can also use ZeroSSL. ZeroSSL is substantially identical to Let'sEncrypt. So their free plan is basically exactly the same as Let'sEncrypt.org. You speak the ACME protocol, which I'll come to in a moment. You send them your certificate signing request. They send you a signed certificate, and the certificate is trusted in every single browser in the universe, and all as well. So far, so identical, exactly the same as Let'sEncrypt.org. But if you like spending money, and you feel that spending money on numbers is something you must do, they also have a couple of plans where they will take your money in return for some features they have. So one of the features they have for a price is monitoring. So instead of you running a cron job every couple of weeks to renew your certificates, they will nag you when it's time for you to renew your certificates. They also offer 1-year certificate validity. Let'sEncrypt certificates, as we'll see, are only valid for 90 days, which forces you to automate, which I think is a good thing. Anything that forces you to automate is good, because then you go and automate it and it can't break because it's manual. The ZeroSSL folks will give you a certificate that's valid for a year if you give them some money for it, and then you're in the same situation as the traditional model, where after a year and 2 days, someone comes and screams at you and tells you, "Oh, your certificate is broken." They also have some extra APIs you can use. So if you don't like the ACME protocol for whatever reason, can't think of one of those reasons, they also have a REST API, and they have some technical supports, which I don't know. I've never tried these people. I just heard about them today when I was updating the slide deck. So apparently they give you tech support. But this talk is about Let'sEncrypt, and it's free, and we can have a spirited exchange of views about why free is good later on after this talk. Having said that, please do interrupt me if you have any questions. I don't bite. I like them. I like an interactive presentation. I miss teaching in person. So how does this Let'sEncrypt protocol work? Ultimately, you imagine you are the web server administrator for something called example.com. You go and tell Let'sEncrypt that, "Hi, Let'sEncrypt, I am example.com." Let'sEncrypt will say, "Yeah, I don't believe you, but you can convince me that you are example.com if you put a file on your website called A303, and in that file you put the text ED98, and then you should sign this with the key you're going to tell me." So the web server administrator goes and does exactly that. They put the magic string ED98 at the magic URL, and they go and sign it with the magic string they've got. It's a little bit more involved than that, but they send the magic number back to Let'sEncrypt. Let'sEncrypt says, "Okay, I see your challenge response. I see it in the right place, and I see you've included my magic number. I will believe. I will accept that you are who you say you are," and they will issue your certificate. Great, wonderful. That was a 2-picture overview of RFC 8555, which has the lofty title Automated Certificate Management Environment, also known as ACME. The RFC is remarkably readable. It's not a scary document, and certainly nothing as scary as, say, X509. This ACME protocol you talk to Let'sEncrypt.org or to ZeroSSL is basically a JSON-based protocol over HTTPS. So you send a bunch of strings marshaled in a JSON file, and you fire that over HTTPS, and they speak HTTPS back to you. And there are several implementations of this protocol, which should make anyone interested in standardization feel good. They have a reference implementation called CertBot, which I'm sure several of you have used. It's a reference implementation, which means it implements the entire protocol exactly as written. And like every other reference implementation, it also developed together with the protocol. So it is, compare it with Bind, right, which is the reference implementation for the DNS. It's a big application. It's got a lot of dependencies, and it makes many assumptions about what kind of environment you're going to be in. And it lacks elegance because it was not made to be elegant. It was made to implement this nice new protocol. So I'm not going to talk about CertBot because I like software that has a bit more elegance to it. What I'm going to talk about is something called acme.sh, which is a teeny tiny shell script. It is written in pure POSIX shell. It has no awkward dependencies. You can run it on any POSIX-like system that has a shell. So it doesn't even need bash. It just needs a shell, which is really quite nice. There are many other clients. The last time I looked at this list, which was in November last year, There were over 100 in about a dozen different programming languages and environments. So, if you can't find what you like on that list, write your own and put it on the list. The protocol is open, but I'm going to talk about acme.sh because it's really simple and it shows the automation features of the protocol off really well. So first of all, you need to get acme.sh on your system, and you basically do that by cloning its Git repository and running the shell script. Or you can, if you're that sort of person, you can curl get.acme.sh and pipe it to your shell. Note that I'm doing this as a regular user. I'm not doing this as root. Don't curl things into your shell as roots. That's a bad idea for so many reasons. But the installer does three things, and you can go and read this shell script. It's remarkably readable. First of all, it goes and copies itself into a .acme.sh directory, which is helpful because it allows you to update it automatically as well. We'll come to that again. It sets an alias in your .profile file, and it creates a daily cron job to check and renew certificates for you. So that's all it does. It's really quite simple. And with this shell script, you can go and issue certificates. And like most of the software I teach, it's the sort of software you don't need a manual for. You can guess these command lines. acme.sh -issue -the example.com will issue a certificate for example.com. And in this case, it will use a web server. It will expect a web server for its tokens. And the three first examples are basically the same thing. If you want multiple domains in a single certificate, you just list multiple domains and the rest of your arguments are the same. This is web server mode. I'm not going to talk about this much more. In this mode, it's morally equivalent to how certbot works, in the sense that you'll have a web server on your machine and the shell script will drop your challenge somewhere where the web server can see it. And it will speak acme.sh protocol or ACME's protocol in the background. So this is not very exciting. But where acme.sh really shines, or where the ACME protocol really shines, is that there are many opportunities for automation beyond running it as a web server. One thing that acme.sh supports is something called standalone mode, where you can run this on an internet-facing machine, and without having a web server on this machine, without anything else, you can issue a certificate as if you were a web server. You'll still require privilege to bind to port 80, which on most platforms means you need to run as root. And it still requires a publicly internet reachable machine to issue a certificate like this, but you don't need a web server. You don't need to configure Apache or Nginx to define files. So that's a useful sort of mode. I never use it. The mode which I'm going to talk about is DNS mode, which is where the real magic is, because in DNS mode, all you need to issue certificates is you need control over the DNS. And actually, you don't even need control over the entire DNS. All you need is you need to be able to insert text records into a DNS zone. And we'll come to that in a moment. So if you can add text records to a DNS zone, you can automate all of Let'sEncrypt and issue your certificates without exposing your machines to the internet. So with this DNS mode of acme.sh, you can have one machine, certbot, which talks to the Let'sEncrypt server or the ZeroSSL server. I keep reminding you that it's the same thing, and it can issue certificates for machines that are deep in your network and may not have any internet connectivity at all. So you can issue certificates, Let'sEncrypt.org, trustworthy certificates for things like your printers, for things like your local management machines, your local monitoring, your routers, your switches, anything that you might have a web interface on, or anything that you might want to authenticate in some way, for whatever reason, you can issue a certificate for without putting that machine on the internet and without putting that machine, without putting a web server on that machine. So in addition to generating certificates for network infrastructure that should not be exposed to the internet, this means you can also issue certificates for systems that are too weak to generate their own certificates. So you could have little microcontrollers, say, if you have some light strings and you have a little ESP32 or ESP, what is the 8266 microcontroller, which is just powerful enough to run a web server with SSL encryption, but it's nowhere near powerful enough to generate keys. You can generate the certificates for this tiny little microcontroller offline, and all you need to do is deploy the keys and the certificates. And obviously you can automate this, and you don't need to expose the little microcontroller to the internet, and you don't need to generate keys on the microcontroller. So that's just some of the things you can do with this. I'm sure there are other use cases I've not considered, but the fact that all of your interactions are with the DNS rather than with the end node where the certificate will be deployed is extremely powerful. So before I go into the actual demonstrations and interactions with this thing, I'd like to have a very brief digression about limits. So usually what happens after I give this presentation or give this workshop, people go off and they go and replace all of their expensive certificates with Let'sEncrypt.org certificates in one go. And then they come and shout at me because after a couple of certificates, Let'sEncrypt or acme.sh starts giving them errors and starts yelling at them. The limits of Let'sEncrypt.org are generous, but they are firm. The moral of the story is don't test in production. If you start generating a modest number of production certificates and all of them work and they're all issuable in one go, then you're not going to run into these limits. If you're going to try, fail, you're going to run into the limits and you're not going to have a good time. The key limits of Let'sEncrypt.org, which you're going to run into, are you can have a maximum of 50 certificates per registered domain per week. So in a 7-day period, you can register 50 certificates per domain. And a domain is usually it's a top-level domain. So trouble.is or nog.ke. 50 of those you can register per week. That's pretty generous, right? Because every machine only needs one certificate at most. Also remember that if you're doing something like virtual hosting, you can stick up to 100 subject alternative names into one certificate. So if you run into this, if you're going to run into this limit, you have a bigger problem that you need to think about first. It's worth remembering that renewals don't count to this limit. So you can renew any number of certificate per week. There is a limit, but it's pretty soft. To give an example, the FreeBSD.org cluster, we have, I think at last count, we've got about 800 certificates. On any given day, there's at least a bunch of them that are renewing. We never run into the limits. We never run into the renewal limit. We never run into the issuing certificate because we usually don't register 50 certificates in a week. Duplicate certificates, you can have 5 a week. This is, you already have a certificate for, say, lists.nog.ke, and you're now renewing it, and then you issue a new one for the same name. You can only do it 5 times because that usually means something is wrong, and the system wants to give you an error to go and look at why are you getting multiple certificates for the same name. This is clearly a misconfiguration. So the system will fail early and it will yell at you. Failed validation, same thing. And this is a limit you're definitely going to run into, especially if you're setting up the DNS system I'm about to demonstrate. Failed validation, you have 5 failures per account, per host name, per hour, which is a sliding window. But you run into this really quickly if you're testing in production. So I try to add it and it doesn't work. Oh, let's try again. That's your second try. Oh, I fixed something in the DNS. And then that's your third try. Oh no, I forgot to update the serial number. That was your 4th try. And then, oh no, I forgot to reload the zone. That's the 5th try. So you've had your 5 attempts. You are now in the timeout box for 1 hour. There's a couple more rate limits. You can go look them up on the webpage. ZeroSSL, the people you give money, also have rate limits, and they're similar to these. But the moral of the story is don't test in production, and I'll come to that in the demo in a moment. Any questions so far? I see the chat window has a couple of things on it. Please use the slideshow so we can see the slides clearly. Okay, good. Yes, I've done that. Feel free to post your questions here. Yes, good, excellent. Please interrupt me if you have questions. I'm going to stop my slideshow now, and I'm going to do a quick demo. If I can find the stop button. There, 2 blinds. Ooh, more people have trickled in, that's good. Find a window, find this window, and then share this window. Share screen, that's the one. Is this little window visible?
Yes, it is.
Excellent. I am going to issue a certificate, and for this demo, I'm doing this on a real-world production domain, which I care about a lot. It is trouble.is, that is my domain. I am going to ask ACME to please issue me a certificate, and the -K 4096 means I would like to use a 4096-bit RSA key. I think this is the default now, but I like to be explicit about my key lengths. The domain I want the certificate for is KeNOG demo.trouble.is. I put this domain in my DNS earlier today, and I'm going to use the DNS I set up in Microsoft Azure for getting the certificates. And then there's a challenge alias, which I'm going to come to in a moment. But I type this command, and then I watch it blow up in my face. Hasn't blown up in my face yet. So what it's doing now is it's adding a text record to the DNS, and it's adding it to ACME challenge.certbot.trouble.is. If you're keen, you'll have noticed that I use this challenge alias here to the command line. I'll come to that in a moment. So it has now added a text record to my DNS using the Azure API, which I'll talk about at length in a moment. ACME is validating this, it's verifying that it exists, and eventually I will get a certificate. There we go. This blob of text should be familiar to anyone who has played with certificates in the past. It's a base64 encoded version of the certificate. Here, if I take this key. Let's see if I can type and think and type at the same time. What was the trouble that is? No, I need to, well, okay, I can't think and type at the same time. If I were smart, I would put this in a buffer, type the buffer, but I'm not smart, clearly. I want the whole key. There we go, this, and this is the file name I want. So I take this I take this key and I transfer this key in a secure fashion. Oh, Zoom interferes with my copy and pasting. So I take this key and I transfer it in a secure fashion to another machine. So let's stop this share and share another screen. The secure fashion I'm using to transfer my private key is the tried and trusted you encode and drop it somewhere. So this is another machine running a web server. And if I decode and paste the key, there we go. I have now transferred the key in a secure fashion to another machine running a web server. And if I look at this web server's configuration, I have this domain here. If I give that file the correct file name, it was an RSA key, and I'm sure the permissions were wrong, so I'll just make them right. There we go. I've done that. Now that was the private key. The public key I still need. I'm not going to bother you with the copy and pasting thing of the public key. I will just do that in the background here. Let's do that. Right, and if I just run my magic shell scripts, okay, I'm sorry, I'm fiddling. I'm looking at too many little windows. That this always happens when I'm teaching with Zoom. I can just do a fetch. There we go. And now if I reload Nginx, that should work. So now if you are on a machine that's connected to the internet, you should be able to get to that web page without any difficulty. Let me share that screen. Keep forgetting that you're only seeing one window at a time, which is probably good for you. There we go. So I have just, is the screen visible? I've just generated this certificate, and at no point did I run a web server in generating or getting this certificate issued. All my interactions were with the DNS and with the Let'sEncrypt server. So this certificate was just issued a couple of minutes ago. Of course, this is on local time, and it is now indeed roughly, yeah, that's about an hour ago, and I've just generated it now. So that's good. That was easy. So far, so good. Was there a question? No, that's just Kevin being helpful. So that generates a certificate. Let me go back to my presentation. Now I need to go to share screen and then to my presentation. And then I click the slideshow button. No, go through that. I click the correct slideshow button. There we go. Right. So this was my backup slide. I don't need it. So how does that work? So the way this works is that I've verified the ownership of the KeNOG demo.trouble.is domain by asking Let'sEncrypt to check for a text record. And the script has added its text records to the DNS using the Azure API. And I've added a level of indirection by sending this CNAME verification to Azure. I'll show you in a terminal window what I mean with the indirection in a moment. But I have the only DNS zone that I need to have an API key for, or the only one that the shell script needs to be able to access, is this certbots.trouble.is zone. So that allows me to exercise the principle of least privilege. The only thing that I need to expose to this Let'sEncrypt automation is this one zone, and I can restrict it further to only allowing it to add text records. And this is just one option. So I use Azure because I get an insane amount of credits for free, and I might as well use them. And their API is fairly easy to use once you bend your minds around the studly caps and things. It's fairly simple to use Azure if once you're into it. You can also use Cloudflare. You can use, we'll go through them in a moment. There's about 1 million different options. And finally, you can also just use NS updates and self-host your DNS. And that's a lot of fun, but I'm old and cranky and I've done all this. I don't want to play this game anymore. So I just put it in Azure. You can, the FreeBSD project does not use Azure. We use a pipeline built around shell scripts and make files that would make any sane person cry. But that works too. But if you've got a simple setup, or if you're teaching this workshop, something like Azure is really easy to do. Or if you're already using Cloudflare, it is really easy to use their DNS API, because all you need to do is add a record to the DNS and remove it again, and that's it. What I've not showed you is that acme.sh will regularly renew the certificates. It installs a cron job, and every day, I think it is, it wakes up and checks, do I have any certificates that need to be renewed? And it goes off and renews them. So let's look under the hood at how this stuff all works. So I'm going to make this screen go away again and bring up my terminal window again, if I can find it. Here it is. No, stop share and reshare. that one. Yes, share. There we go. Earlier today, I set up a brand new ACME installation in a brand new jail with nothing in it other than I have installed Git, I have installed curl and its dependencies, and that's all I have on this jail. And I have put in, I have downloaded I have not even bothered to set up any shell aliases. I have downloaded the ACME shell scripts using Git, and I've put it here. I've done the install thing. So now I have in my, why did I do that? Go there again. So this shell script, it's not very big. It's a 6 megabyte shell script, of which most of the shell script, well, most of that is, it's a 5.6 megabyte Git repository and about a 1 megabyte shell script, which is actually fairly substantial. But let's look into this directory for a moment. We see this DNS API directory, which is quite exciting. And these are the DNS APIs that Let'sEncrypt, that acme.sh currently supports. So the one I was using was DNS Azure. If we look at that one, let's not read it line by line. It's a fairly straightforward shell script. It looks at the environment for your Azure tokens, and it goes and speaks curl at the Azure API. There's a whole bunch of others here. There's Cloudflare is definitely here because I use it for another installation. It's called CF. DNS CF is Cloudflare. HE is Hurricane Electric's free DNS. You've got, what else have we got? DNS NS update is the old and trusted send an update message to your DNS. You've got DNS zone, which adds a line to a zone file, and then you feed it to your own DNS server. Anyway, there's plenty of examples here which you can play with and customize, and more than likely there's one here that does what you want already. So that's the getting the certificate or the issuing the certificate side of the story. Equally exciting is the deploy directory that you've got here. The deploy scripts allow you to do something with your certificates once you've had it issued. So I haven't got the history anymore. Oh, yes, I do. Here we go. Stop scrolling. Stop scrolling. Okay. When you issue your certificate, you get it on your terminal. Okay, scrolling is a bad idea. It tells you that your certificate has been left in this directory. And that's not very exciting because this certbot thing is going to be run automatically and headless. But you can install a deploy script which does something to these scripts. So the way I do it, if you saw me doing it earlier, I fetched a file from certbot.trouble.is. What my deploy script does is it drops the certificate, not the private key, just the certificate. It drops it somewhere a web server can see it. And then I have another script, which I can show you. It's in Chrome. Another script that goes and downloads the certificates. This runs every night. It goes and checks, is there a new certificate there? And it just goes and downloads this. This deploy script can be quite complicated as well. If you wanted to, if you ran certbots or acme.sh on the same machine as your services, your deploy script could actually install the certificates in, say, your web server configuration and then restart the web server. If you are running something like Ansible for automation, you could have your deploy script run some Ansible playbook. Or if you're, well, there's other ways of doing it the way I do it. You put it somewhere where something else can find it, and then run another script over there to do it. The possibilities are endless. Ultimately, you're working with a bunch of files. The way we do it in the FreeBSD cluster is we drop the certificate somewhere on the file system, and then something else mounts the same file system, and we we poll it from there, and then it ends up on the other systems. So there's endless possibilities with this model. All you need is this one machine or this one jail or container or what have you that sits there and runs acme.sh and issues certificates for you. And this was a machine. This was a very simple and convoluted demo. Now let's go on to a more interesting demo. Please do ask questions if you have any. I have also set up in Azure. If I stop sharing this window and I start sharing another window, I think it's this window. Yes, that's not an embarrassing window. It's a good window. Oops, stop. I have set up a new DNS zone, KeNOG.trouble.is, and I've delegated this to Azure. So this entire subdomain just lives under Azure, and I can put things in there. So I've already put in an acme challenge.demo. So what this does is there's a host called acme_challenge.demo.kenog.trouble.is. Note that there's no demo host in this zone file. All there is this acme challenge demo, which I put in a DNS. I've also created I'll show you that in the slideshow in a moment. I've set up access control so that I can use the API to manipulate this zone. So if I go back to my terminal window again, question, I see question.
Yeah. Question, Philip. So this is Kevin. Just trying to understand the acme.sh properly. So if I want to use it on my server, so I use Let'sEncrypt certificates, okay? And when I want to generate a certificate, it will check if there's a web service running, and then to use that to authenticate, yeah? So for acme.sh, from the demo you've shown, there's no need to run a web server. It doesn't need to check port 80.
Yeah,
that's correct. Okay. So on the server in which I want to run the certificate, do I need to have the working DNS zone? I think that's the connection I've not made.
No.
Where?
No. So, the way you can run acme.sh in the same mode you're running certbots. So you can run it on a web server machine, and it will work in exactly the same way. So if you have a web server on your machine, you can get rid of certbots and its million dependencies and replace it with acme.sh in web mode, and that will work. The mode I'm demonstrating is a DNS mode, where instead of putting challenges on a web page, you're putting your challenges into the DNS. And what I've just showed you with the DNS API plugins is that there's an endless range of possibilities for getting access to your DNS. So the way I get to my DNS is I use Microsoft Azure. You can also get to, if your DNS is hosted by Cloudflare, you can use Cloudflare's API. If you run your own DNS, you can run NS updates. If you have a fancy DNS pipeline where you generate your zone files, you can write a line to a file and reload your DNS. So it doesn't really matter how this text record gets into the DNS. As long as a text record gets into the DNS, acme.sh can use it.
I see. Thank you.
Does that help? So I'll actually show this now on this KeNOG.trouble.is. Am I still sharing my screen? No, I'm not. And that's okay. Let me share another screen. Let me share the little window here. I think this is a good window. Yes, this is a very nice window to share. It's very pretty, and it has no secrets in it. So imagine that I would like to issue a certificate for demo.kenog.trouble.is, and I would like to issue one. Let me issue the certificate, and I would like to use my KeNOG domain. So I'll put in DNS, use DNS Azure. I'll show a little bit more about that setup in a moment. And then I'll add the challenge alias. So what this says is, dear acme.sh, please issue me a certificate for demo.kenog.trouble.is. Use the Azure DNS. I'll show the configuration for that in a moment, and use the challenge alias kenog.trouble.is. What that means is, instead of creating a text record for this name, demo.kenog.trouble.is, create your challenge under this name instead, created under kenog.trouble.is. This restricts how much of your DNS you need to show or you need to expose to this API or an API. You can, if you want to. There's nothing wrong with creating your text records under this namespace. I just like to narrow it down further, and I'll show that in a moment, to this namespace, because that allows me to have exactly one text record that an API needs to be able to access. So I run this script, and while this script runs, domain's not changed. I did this earlier. So this is where we go and try out the limits, right? So traditionally, when I run this, I run into a hard limit and something cries, but not today, maybe. All right, there we go. So added text record. So now I quickly stop sharing. In the next 20 seconds, I would like to share my other window, because I've forgotten foolishly to make the timeout longer, because I'm not a smart man. So I refresh, and now what it's done is, you see a text record has been added to the DNS. If you're familiar, Kevin, with certbots running on your web server, this will be familiar to you, right? You'll get this magic string, but instead of the string being in a file on your web server, it's in the DNS. So now let me stop sharing this window, because meanwhile, the other window will be done. This window. There we go. So let me scroll up a little bit. I've not put a web server on this domain. I'm not going to bother. But we saw that so this is what I typed. Click. There we go. It has added this text record, this ECM, blah, 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 blah. It's added to a text record called acme.challenge.kenog.trouble.is. This is the only record in your DNS that this is going to operate on. It's added the text records, and now the shell script has gone to sleep for a bit. I've set the sleep time to very low, 20 seconds, because Azure's DNS is really, really fast. If you're running your own DNS and you have a long pipeline, you might have to sleep for 30 seconds, half an hour. If you need to give your text record to someone else to type into the DNS laboriously, reload the zone file, that also works, by the way. You can do that. The timeout will just be a lot longer. And you have to ask yourself whether it's worth automating if that is your DNS pipeline. But ultimately, the challenge is validated. Instead of checking a web page, it's gone and check the DNS. And Let'sEncrypt.org is happy, and it issues my certificates. And from then on, it's just a deployment pipeline. So that was demo. Now let me unshare this script and do this again. Let me go to share this window again. So imagine I have bought a new printer for the KeNOG, which is on the other side of the world for me. But that aside, what I do, so I have, I don't have this printer. I will just add underline ACME challenge.printer, say. So I create a level of indirection, ACME challenge.printer.kenog.trouble.is. I add a CNAME, which points to, I spell it right, it works better. So I just add a CNAME for this ACME challenge.printer. I add it to ACME challenge.kenog.trouble.is. That means that I can validate that challenge by checking this challenge. So I've created a level of indirection. This name needs to be exposed to the DNS, but the name printer.kenog.trouble.is is not exposed to the DNS anywhere. So your printer lives inside your network somewhere and presumably has a local address, doesn't have a routable internet address, certainly not an internet address that I can get to from Hong Kong. And it doesn't even need to be in the public DNS. So you can run your split horizon DNS for your infrastructure stuff deep inside your network. The only thing you need to expose to the public DNS, and not even very public DNS, is this one CNAME. And this domain could be anything, right? So I've just done it kenog.trouble.is. This can be anything else. So I run my cert bots running on my infrastructure. We do certificates for people with a lot of different domains. So the exposure, even of your namespace, is very limited. So I go and create this CNAME, which will end up in the DNS in very little time. So I stop sharing, and I share my my other little terminal again, this one. And if I run this again using printer, there we go. So remember, printer.kenog.trouble.is is not visible in the public DNS. The ACME challenge.printer.kenog.trouble.is points at ACME challenge.kenog.trouble.is. I can go and issue the certificate and it will say, this is fine. So it's added my text record to the DNS, and 20 seconds later, I will have a fully trustworthy Let'sEncrypt certificate, which I can put on my printer. So anyone who wants to print on, well, not my printer, your printer, a printer which possibly doesn't even exist, but anyone who wants to print to that from their Mac or their Windows machine or their Linux machine using cups or whatever it is, will have a trustworthy certificate. There it is. Now the certificate is issued. Now the deployment of the certificate is just another challenge, which I can talk about for a lot longer. Does that make sense roughly? Hope that makes sense. Let me go back to my presentation for a moment, if I can find it. Here we go. So the way I've done it.
You continue.
Yes.
Maybe I can pop a question.
Of course, yes, please.
If I was interested in generating a wildcard, for example,
Yes.
how would the process look like?
The process would look substantially identical. You can probably guess. I can't actually remember what the challenge looks like for wildcards. I would have to look that up, but you can. Let me read the man page for a moment. First of all, you should evaluate whether you really want a wildcard. Usually, you don't want a wild. Usually, when you think you want a wildcard, you have another problem which you should be solving first. But you can issue wildcard certificates with acme.sh. I just never remember the syntax. It's on their wiki somewhere. Oh, it's actually, it is exactly the way you think it is. Of course it is. Let me put this window back. Share this window. You're going to be shocked to learn that the way it works is like that. But you probably need to quote it because otherwise it's not going to work. I have no idea what challenge alias it's going to be, but this is where we get into the don't test in production. So what I'm going to do is I'm going to add a -- server, Let'sEncrypt -tests, which uses the Let'sEncrypt staging server, which has much more generous limits than the real Let'sEncrypt server. And if you spell server correctly, things work a lot better. Oh dear. Okay. Have I done something wrong? Okay. See, this is why questions are fun. I think is it underline test? There we go. Something's right. So it's added that value. And this works exactly the same way. It's now going to validate this, and you're going to get a wildcard certificate out of it in exactly the same way. Probably. If it doesn't work, we have something fun to debug together. There we go. Ta-da! You have a wildcard certificate.
Thank you very much.
So, but yeah, so it's remarkably straightforward. But remember, wildcard certificates are evil. Well, they're not really evil. They're just they are indicative of a problem rather than a solution. Usually, when you find yourself needing a wildcard certificate, what you really need is better DNS management. Or better certificate management, because the problem with a wildcard certificate is you cannot make exceptions. This wildcard is valid for anything under that namespace. So that's one problem. If your wildcard certificate leaks, someone can use it for something that is not yours, which is not great. Another problem with a wildcard certificate is revocation. If your certificate leaks, or you lose your private key, or for whatever reason, you need to retract or revoke your wildcard certificate, you need to replace every consumer of that certificate. And because the wildcard matches an infinite number of strings, you need to go and find that infinite number of strings. And what invariably happens is you miss at least one of them. So when you need to go and replace a wildcard certificate, you forget at least one place. And the time you remember this one place is when 40 people are screaming at you, why isn't it working? So a wildcard certificate, I cannot recommend against it strongly enough. It is a lot easier, and especially with acme.sh, it is a lot easier to manage hundreds of named certificates than one wildcard certificate. Does that make sense? But you can issue.
Yeah, sure.
I'm
also not a fan of wildcards, especially with Let'sEncrypt. So yeah, that makes perfect sense.
Yeah, so you can issue them. It is all possible, but the system gives you just enough rope to hang yourself. But the same caveats apply to Let'sEncrypt wildcards as to any other wildcards. And I really like that acme.sh, I can have a list, and then I just go through all of these names and I know exactly where my certificates are. And the deployment is really easy as well, because it's also just a shell script. So yes, I have just learned or relearned, I'm sure I've done this before, how to generate wildcard certificates. And the indirection also works. So you just need access to one text record in your DNS, which was where I was going. I opened this window again. So the way I did this with Azure is I just created a resource group for the purpose of this workshop. I created a zone KeNOG.trouble.is, and then I created a service principal which has permission to modify that zone. I could have restricted that further to the text records, but I couldn't remember the syntax, so I didn't. And then I added it to the ACME users environment. So that I should probably make this slide show bigger again. There we go. So the way that works is I typed AZ network DNS zone lists in the resource group KeNOG, and I spat out its ID. And then I said, create a role-based access control token called KeNOG ACME DNS validator, which is a DNS zone contributor and has access to whatever came out of the previous commands. And ACME or Microsoft's Cloud Shell then goes and say, here is your credential, and here are all the secrets which I am happily spitting out in this presentation, because you have access to exactly one DNS zone which will disappear in an hour or so. So that's why I like I really like the fact that I can restrict access to exactly one text record or at most one zone. It makes it gives me a level of comfort when I'm dealing with an API and I don't have to give it access to more than what it strictly requires. So that's using Azure. That's what I use for my demo, and it's also what I use for my trouble.is. I run my own DNS for trouble.is, but I delegate certbots.trouble.is. I delegate to Azure, so that this little sandbox where I can generate my challenges, and it costs me nothing. And it's fun. If you wanted to do this with any other free DNS provider or with your own DNS provider, you can go and do that as well. Using Cloudflare, it works exactly the same way. You get an API token and you restrict access to it as much as possible, and you set some environment variables and you're done. The reason I don't use Cloudflare for my domain is that Cloudflare's DNS only operates on Apex domains, and I will be dead before I give my DNS Apex zone to someone else. I'm happy to delegate one name for the purpose, but I will run my own DNS. They will, they can pick it out of my cold dead hands. I'm sure others have other red lines, but so you delegate certbots. Or if you want to run everything yourself, you can do that. As I said, the FreeBSD cluster does exactly that. We use a makefile-based pipeline which generates text files which are added to the zone, and then make runs NSD reloads, and it works. It works exactly the same way, and it takes exactly as long. It's just a different API. This was just, so this is what I have in my trouble.is DNS. I've got certbots delegated to Azure. You can delegate it to someone else, or you can run it in-house. Fundamentally, at the end of the day, the only thing that matters is you must be able to put ATEX records into the public DNS. And that was all I have. I was hoping to have a spirited discussion for the remaining time and answer any questions, and hopefully this will have been useful to you. There will be more encrypted things in Kenya.
Thank you very much, Philip. That was really informative. I've also learned a lot. I can't find any question on the chat box. So maybe you can allow me to digress a bit. I know you focused more on automating the ACME challenge, moving it basically from doing it with a web service to basing it on DNS. Huh? So yes. In terms of deployment, I wish you spent a few minutes on that, because
yes,
and I appreciate you're a FreeBSD or Linux person, but for someone who is on Windows, I'm sure a huge community is on Windows. Then how would life look like for them, given that some of these systems actually require you to have certificates in combined format, maybe a .pfx format, or yeah. So
right. Yes, these are good questions. Let me share another little window. Let me give you a glimpse into my into my life. So this is yes, this is my certbot, my environment. So I don't really know how you would deploy things on Windows. I think you can run acme.sh on Windows using the I think modern version of Windows come with Linux inside it, I think. And historically, Cygwin exists and has a shell and has access to the file system. So you can do all of these things on Windows, because at the end of the day, it's acme.sh is a really, really trivial shell script. It operates on files and it uses curl to talk to the internet. Both of those work fine in Windows on Cygwin, and I'm sure they work fine in the Linux stuff that Windows ships with. I'm largely ignorant of how the Linux environment on Windows works. My interactions with Windows have been few and unpleasant. But the deploy scripts are actually kind of fun. So if we go into into the deploy directory. The script I use is, which one's me? Oh, this one's me. The script I use, this is the script I use. For some reason, it's spelled bash. I think I must have been drinking when I wrote this. This is just normal boring shell script. I set the variable outputs. This is where I want my certificates. I check if it's an ECC key, so acme.sh. I've not talked about it, but it can do RSA keys, but it can also do ECC if you like your crypto elliptic rather than modular. And all I do is I copy my full chain, so my PEM file, I copy it to this directory. In this shell script, you can do anything you want. You can do things like where am I? Oh, it helps if I type in the right window. You can do things like OpenSSL PKCS 12 export out, your name here, text and then minus in key. You have full control over all of these things. So you can generate a PFX file, and at the end of the script, you copy that PFX file somewhere. So that's something you can do. The way I do it is I just drop my PEM file in a directory where a web server can see them, so that I can just use HTTP to fetch it on my consumer machines. If you had a pipeline that required PFX files, you can generate your PFX files here. The downside is that with your PFX file, so PKCS 12, you also have your private key in there. So your deployment challenge becomes a little bit more interesting because you need to deploy securely. You can set a password on a PKCS 12 file, but it's still a lot weaker than not having your key somewhere visible. So if you can change your deployment pipeline in a way that your key is distributed out of bands, it's a lot nicer. And actually, that brings me to another point. Certbots, the reference implementation, it goes and generates a new key every time you renew your certificates, which it works. But the ACME protocol does not require that, and X509 doesn't require that, TLS doesn't require that. You can reissue a certificate without changing the key. And that's one feature I use in my deploy pipelines, and which we use in the FreeBSD.org cluster as well. We generate a key exactly once when the service is born or when the host name is born. We generate the key, and then we securely move the key to the machine where it will be used. At the beginning of my presentation, I just copy pasted it with UU encodes. There are more elegant ways of doing this. But once that key is where it belongs, I delete it from certbots, and the key exists in exactly one place. It exists on the machine that is using that certificate, and the only thing that needs to be deployed is the public key. And I don't think you can do that in a PKCS 12 world, because I think you always need the key. So I might be misremembering. Am I misremembering that? PKCS 12. Oh, no, it's PKCS 12. I think you always need the key. Oh. Help. No, you can use PKCS 12 without keys. So I'm misremembering. Yes. So you can do exactly the same thing I did. And in your scripts, instead of copying your PEM file directly, you wrap your PEM file in a PKCS 12 PFX file, preferably without the keys, and then you can distribute it in the same way as I did. It's really simple to just drop them in a web server and then fetch them. So I have a little shell script somewhere here. Oh, where am I? Oh, that's not where I want to be. My shell scripts. My shell script just has a list of domain names which it goes through, and then I go and fetch the certificates from the web server. This runs every night, and if something needs to be done, I set a reload flag, and then if the reload flag is set, I reload the service. So that's one thing. That's a very basic deploy pipeline. In this deploy script, you can do literally anything you want. It's a shell script. So you can call other APIs. You can, if your infrastructure is in Amazon or in Azure or in any other cloud service, you could have your deploy shell script talk to this cloud service and send an API call to them with a new certificate. This is all within the realm of possibility. It's just a shell script. Does that help answer your question?
Yes. That's in order.
Yeah. So it moves the problem domain. It takes the whole verification. It makes that a solved problem, and then you can focus on the interesting problem, which is how do I get the certificate to where it belongs?
Okay. So there seems to be no more questions on the chat box.
That means I should share my email address because it's often that people are stunned.
If you can. Maybe the audience is a bit shy. or it got very technical and
I have never bitten anyone over Zoom, I promise. I've never bitten anyone in a presentation. I think there's at least a couple of people in the call who've sat through my presentations in the real world when we could still travel. I don't think I've bitten any of them.
So maybe now that there is no question, I can digress again and focused on acquiring the certificate and renewing it.
Yes.
What about the revocation or reversing the process, revoking it?
Yes, I'm sure you can guess how revocation works, right? So if I go back to this little window and make sure I'm in the right window. So earlier on, I typed, I issued this wildcard certificate for you because you wanted it. Now, if I wanted to revoke this wildcard certificate because we can agree that it's a terrible idea, what do you think I would type here? You're allowed to guess. I typed issue to issue a certificate. What do you think I should type?
Sorry, I was on mute. I was saying revoke.
Yes, it works better if you're on mute. There we go. So I could just revoke the certificate, and this was on the Let'sEncrypt test server. Let'sEncrypt test server, and you don't even need the DNS for that. You just okay, that's an interesting error.
But it says revoke success.
Oh, revoke success. Okay, yes.
Yeah.
Because it was trying. Oh, it was trying the domain key, and the domain key will not exist because it's a wildcard. So it uses the account key, and then it's successful. So that's a bit of a far digression. But Let'sEncrypt, you have two keys. You have an account key, which protects all of the names, all of the certificates you have issued, and then per domain you have a key as well, which protects that single certificate. So you can, ACME, the ACME protocol itself internally within the protocol also practices the principle of least privilege. It doesn't use a key with more privilege than it really needs. But to unwind my mental stack, to revoke a certificate, you just type acme.sh -- revoke, and it will revoke it. And you don't need the private key for this. You don't need the public key. You don't need the certificate itself. You don't need. All you need is your account key, which is created the first time you use acme.sh.
Okay, perfect. It's clear. I think let me not buy any more time. There seems to be no more questions from the audience. Thank you very much for finding time to be with us and do such a nice demo.
Thank you for having
also
me.
to the participants, thank you very much for joining. I hope you've learned something. We will try and share the meeting recording so that you can. And I know some of these commands. You went quite quickly, and it's only fair that someone reviews very slowly and goes through it over and over again. So thank you, everyone. I think we can end it at that if everyone is happy. So thank you, and have a good afternoon if you're in Nairobi.
All right.
Thank you
for having me. Have a good afternoon, and I will share my slides with Saruni, and he can share them with you.
Good. Thank you. Bye.
Bye.
Thanks, everyone.